Hello, we have some people here. Yay. Hi, guys. Hi, Anthony. Hi, Brittany. Hi, Carisha, Catherine, Lindsay, Mariella, Michelle, Nana. Got some initials, AEPR. Cool. Barath, Caitlin, welcome. Um, Hello. Hi, Olga. Cool. Welcome to our tonight's free GRE prep hour. One function we're going to be using, one function we're going to be using a lot tonight is the chat. So go ahead and find that chat function. Change the to field to all panelists and attendees, and then chat in and tell us where are you signing in from. So let's see if we can get the chat working. Denver, nice. Must be snowy there by now. Cool. Chapel Hill, nice. Cool. Yeah, it's been cold. I'm in Brooklyn, New York. I was in Boston for Thanksgiving. It has been super cold here. California, I hope you're okay with the fires. My friends were all trapped inside. Atlanta, more warm places. I'm jealous. Someone else from New York. Michigan, nice. More California. Ooh, Barbados. That's got to be beautiful. I wish I were in Barbados. Seattle, Florida, Bloomington. Awesome. I'm curious, have you guys ever been to one of these free prep hours before? Or one of our free events? Okay, Lindsay has, but for the most part, first time. Awesome. And one more question as we get started. When are you applying? Or when are you thinking about taking the GRE? Are you at the start of your studies? Are you in the middle? Are you in your last push? Nice. Those are two extremes, 2020 versus 1 month this Saturday. Awesome. Cool. So a mix, people who are in the final leg, people who are just at the start. Excellent. All right, cool. Mariella, I just saw your question. When you see two, if you click on that little gray box, there's a drop down. So you can change it from all panelists, which will just go to me, but all panelists and attendees. Bilal, are you taking the GMAT? This is going to be a GRE presentation, but I think some of this stuff will still be useful. You got it, Mariella. It's still going to be useful for GRE as well. Yeah. We do both GMAT and GRE, but tonight's is GRE, but it's going to be quant. We're going to talk about stats, and I think that this stats stuff is going to be helpful for GMAT too. So up to you. You're welcome to stick around. I think you'll still get something out of it. Cool. Welcome. Like I said, my name is Kat. I teach the GRE for Manhattan Prep, and I work on our GRE curriculum as well. Most recently, the project I was involved in was making Interact, which is our asynchronous online course. So a self-study at your own pace, but totally interactive, comprehensive online course. I am also an instructor manager as well as an instructor, so I work with about 30 of our instructors around the world on things like professional development and training and responding to emails in a timely fashion and all that fun stuff. Yeah, Mariella, I'll try and say a couple words about at the end about it. For sure. And if you have specific questions, you can ask as well. But we have a ton of stuff to cover tonight. So let's, Ken, I don't know what the OAR is. Interesting. Yeah, I don't actually know. I don't know anything about that. Maybe you can chat in a little bit about it. Okay. Is there a quant section on it? Because we're going to do quant tonight. Actually, one of my current students is a naval officer in San Diego. He's doing GRE, but he's very cool. Okay. Excellent. Yeah, so I think this math will probably be applicable to that as well. Most of the problems we're going to do tonight are from this book, our 5-pound book of GRE Practice Problems. If you are in the market for one book and that's all you want, I would recommend this book. It's literally 5 pounds. It's enormous. It has a ton of different problems in it, all the problems you would really need. I can't imagine you would need more. and it's divided up by topic. Oh, yay, you use it, Mariella. Awesome. Yeah, divided by topic. So you can say, I want to do 100 inequalities problems, maybe not 100, maybe 40, which is 50, which is probably what you need. So I've been teaching GRE for Manhattan Prep for about 4 years. I've been teaching test prep for about 10. Still have not done all the problems in this book. Mariella, you're probably going to beat me to it. All right, so tonight's theme is going to be stats. Plethora is a good GRE word. The plethora of problems in the 5-pound book. We're going to talk about mean, we're going to talk about median, and we're going to talk about problems that compare the mean and the median. So have a pencil and paper handy. We're going to do a lot of math. It's going to be fun. All right. So we're going to start off with calculating the mean. I really like some of these stats concepts because the formulas are really simple. Like geometry, there's tons and tons of formulas. Number properties, there's tons of formulas. Stats, it's just a small handful of things, and we're going to talk about a lot of them tonight. So mean, this is probably familiar to all of us at some point in our studies. Average is sum divided by number. I can also rearrange this formula. So for example, if I have the average and the number, well, I can find the sum. Or if I have the number and the sum, if I have the sum and number, obviously I can find the average. If I have the average and the sum, I can find the number of terms. So being able to rearrange this formula, plug different things in, super useful. Let's try it. Here we go. Here's the list of numbers. Calculate the average. Chat in what the average is. Cool. I'm seeing a strong consensus. Yeah. We have 1 plus 1, finding the sum, plus 3 plus 4 plus 11. And we have 5 terms. So I divide that by 5 and I get 20 over 5 equals 4. Nice. Starting off nice and easy, getting comfortable. What about this? Number 2. I have 5 numbers and they have an average of 14. How do I find their sum? What is their sum? Nice. Yeah, I do average 14 times the number of terms. This is my formula over here. And I then get 70. Awesome. So what you guys just did, these two sort of straightforward mechanics, they're going to let us solve a whole bunch of different stats problems on the GRE. Pretty cool. You guys are doing good, so let's start getting a little more complicated. I have a set of 5 test scores that has an average of 22. If I add a 6th score of 30, how much is my average going to increase by? Just give you guys a minute. This one's a little more involved. Yeah. Hamani, I think you did the calculations correct, but remember to answer the question given. That's often a trick the GRE likes to play. Yeah. Yep. Devil is in the details. Very true on GRE. Yeah, okay. I'm starting to see some good stuff. Anyone feeling stuck by this one? Yeah. Yeah, I can. Thanks for speaking up. I bet you are someone else's too. Cool. So let's talk about it. If I have 5 tests and my Actually, you know what? Let's make a table. I think this is going to be a fun problem to make a table for, because tables are really nice. I love tables on the GRE. Organization, you know, I was just muttering about how details are important. Organization is a good way to keep track of details. So let's make a little table. These tables are great for averages. They're great for ratios. They're great for number properties, all kinds of applications of tables. And I know that average times number equals sum. So let's say at the start, my first case, I have an average of 22 and I have 5 test scores. So what's my new sum? Oh, Monty, pizza sounds good. If I have 5 terms and they have an average of 22, what are they going to sum to? Yeah, we just did this. This is old hat, 110. Cool. Now I'm going to add in a new test. So what's my new number going to be sort of after I add? Cool. And yeah, VA has our new sum because I'm adding 30 in this new test. So I get 140. And now how do I find the average if I have the sum and the number? Yeah, I divide. So I do 140 divided by 6 to find my average. And that's going to give me 23.3, repeating 23 and a third. And now, before I jump to my answer, I check my question again. Okay, I'm looking for increase, not the new average. So I'm going to do new average minus current, and I'm going to get 1.3 repeating as my new average. People who are stuck, do you feel less stuck? You have a question? Yay, good. Yeah. A lot of these average problems, and this is true of other types of problems too, are really about sorting through the information given. And that's why the chart's so great, because it gives you a framework for sorting through that. One thing to keep in mind for almost any quantiverbal problem, there are 2 questions you always want to ask. One is, what is the question asking? And the other is, what info do I have? And if you do a good job of these answering these 2 questions, you can usually move on to the third step. Ken, that is a great question. My answer is that you wouldn't need to. The GRE has a calculator on it, unlike the GMAT. And the average time for a regular quant question is somewhere between 1.25 minutes and 2 minutes. This would be on probably the easier side of what you might see in quant. So you'd want to spend maybe 1.5 minutes or so on it. But you never need to be able to do things that fast necessarily. We will see some cool tricks for working around the calculator tonight on subsequent problems, though. Okay. Yeah. GRE does include a calculator. So when we talk about GRE, we talk about working with a calculator. GMAT does not. So if you ever get a chance to check out like a GMAT free prep hour that does quant, they might have more of a focus on not using calculator. It's a double-edged sword, the calculator. You know, you want to use it sometimes, but you don't want to rely on it too much. All right, new question, continuing to get trickier. Johnny takes 6 exams, and he's going to get a grade that's based on that average. Here are his scores for the first 5 exams. Now the question is, he really needs to get an 80 for the class. So, what does he need? We know what the question is asking. Take some time. Process the info here. Chat in when you're getting there. Also, if you have a question along the way, want to hit, chat in with that too. Hamani, that's good advice. I also have a game that you can play to make your sort of mental math faster. I'll link that in the chat while you guys work on this. All right. Seen some answers come in. Cool. What was your first step? What was the first thing you did in solving this? Yeah, we could make a chart. Cool. So we'd say, okay, if he has, yeah. So if his sort of end, we'll call this start, and we have average, number, sum. So you say like, okay, if he wants an 80 and there's 6 terms, we could do just what Nana suggested, multiply those together, and we say, okay, he's looking for a sum of 480. Now here, I find this sum. And I just add up these 5 numbers. What was the sum of those 5 numbers? Yeah, 390. That's a place where, how many of you used a calculator on this one, out of curiosity? Cool. Yeah, it's not a bad place to use a calculator. I think adding that sequence of numbers, it's enough that it was not efficient necessarily to do it by hand. Yeah. Cool. We get 90. Want to see a way to do this without a calculator? Actually, I don't have a choice. I'm going to show you because I think it's cool. Let's look at a way to do this without a calculator instead of asking leading questions. All right. So actually, before I do, any questions about this, about what we just did? Yeah, Ken, you need non-calculator. All right. So let's talk about it. If I think about an average, like if I'm looking for an average of 80, I'm just going to actually arrange our data for a moment. I'm going to sort of say we're looking for 80. I have 75, 78, and I have 82 and 85. A set of numbers will average to the point that they are all the distances from the average, the point at which the distances from the average balance. If you've done any work with like weighted averages or distributions, that's something we talk about. Like an average is kind of like the balancing point. It's one way of describing like the center of a set of data. So if I'm thinking about, I have a set of data and I want it to average to 80, I think about how each of my terms relates to 80. Like this is -2. Yeah, this is -5. This is -10. So on one side of this data that I'm given, I have -17, sort of 17 below. Now I think about the ones above. Here I have one that's 2 above. Here I have one that's 5 above. So I add these together and I get 7. Now, in order for 80 to be my average, these would need to cancel out. Like I'd have to have -17 on one side plus 17 on the other. So I'd say if I have 7 here, I'm going to need something else that's 10 points above. Like this. 17. Barath, that's true if it's the peak of a distribution is the mean, if it's a normal distribution, like a symmetrical curve. If it's a skewed curve, it's not necessarily at the peak. The median is actually going to be closer to the peak than the mean in that case. Yeah, we're going to talk a little bit. We're not going to talk about normal distributions, but we are hopefully going to get to talk a little bit about distributions. So this is a way to do this without the calculator, to sort of think, how is my data spread out? How do I think about the distances? Isn't this fun, Brittany? I really like this method. This is also going to be handy, yeah, when we talk about comparing problems that compare mean and median, which is sort of where we're going to with a lot of what we're talking about tonight. Yeah, it's way easier. And you don't have to use the calculator. So great for Ken, who doesn't have a calculator, but good for all of us because the calculator is not always that great. If you haven't taken a practice test or an official GRE yet, you'll see that when you try it out. You have to use your mouse to click. It's unwieldy, and it's easy to make small errors with it. So yes, sometimes you need the calculator, but if you can find a cool way to avoid it, you're going to be happier. All right. Let's do one more thing with just mean, then we're going to get into averages. I mean, into medians. Here we go. One place where we often see stats are in graph problems. So I wanted to make sure we looked at least a couple problems involving graphs tonight. Try out this one. How do we find the mean from this graph? Yep, that makes sense, Lindsay, if you read it as median. Yep. Stephanie, I wonder if maybe you found a sum, but not an average, and that's why it's high. That's my guess on it. Yeah. So we are going to do finding a median from a graph. Can I just, how many terms do I have here? 1, 2, 3, 4, 5, 6. If I'm thinking about average equals sum over number. So am I right if I said, oh, 110, 111, 112, 113, 114, 115, I have 6 terms? What do you guys think? No, why not? Yeah, I have to count up each of the bars in the graph. Yeah, so I have 4 here, 3 here, 4 here, 1 here, 2 here, 2 here. I have 16 terms. And then if I'm going to calculate the whole sum, I'd have to say, okay, I have 4 110 readings. And I have 3 111 readings. I have 4 times 112. I have a 113. I have 2 times 114. God, I really hope I'm not making a math mistake here. Hopefully someone will catch me if I am. 115, 130, and then I would go ahead and add all those up. What do I get when I add them all up for my sum? Oh, yeah, you're right. 230. I was like, 230 is not the sum, guys. I have a lot of tips about avoiding small errors that we can talk about at some point because that's my Achilles heel on this test. All right, I got a 1792 and I got a 1903. Let's have someone else weigh in. What is the sum here? Oh, yeah. Yeah, more votes for 1792. Cool. Oh, no worries. It's good to make small mistakes because then you learn like what kinds of small mistakes you're prone to make. Then you're more likely to avoid them. So no need to apologize for mistakes. That's where we learn. If we didn't make mistakes today, we wouldn't learn anything. And I would be sad if you guys didn't learn anything. Cool. So I do that. And then what do I get? 1792 divided by 16. Yeah. Cool. Did anyone do this one differently? Did anyone have a cool shortcut? Yeah. Hamani, you want to try and describe really briefly in the chat what your cool shortcut was? How it worked? Yeah. Averaging together. That's why can you average together the two middle terms here? Yeah. Sort of. It's not exactly evenly spaced, but we can kind of use our balancing around the middle trick here a little bit. Like I know that my average is going to be somewhere around here. So it would be like if I have 4 110s, that's going to be like -8 -3 +1 plus 4 plus 6. And I see like, okay, I'm right. It's a 112. I have -8 over here. Sorry, -11 over here, +11 up here. So I can use that distribution here as well. Oh, that's a good question. These are meant to be like discrete blocks. Like each of these is one unit. That's why there are those dividing lines in them to show that it's not like a fluid thing. It's like each line is one temperature. Yeah. That there's sort of, because these are readings, right? Like if I wrote this out in a list, it would be like 110, 110, 110, 110. Yeah. So thinking about how something centers around the distribution of the data helps. Difficulty level of this problem, I'd say medium difficulty. Yeah, because each of these 110s, it's like each of these is -2 below 112. And so I'd get -8. From each of those -2s. Yeah. It kind of the way that I did that was sort of saying like I think the mean's going to be 112 or close to 112. Let me then check the distribution around 112 and see what that looks like check how it's distributed around 112. 112 also happens to be our median here, our middle value. And so I'm sort of thinking like, okay, does the data space out evenly around the median? Is the mean and are the mean and the median going to be the same? Not necessarily. There are 1/3 of all quant problems. So it's a good question. 2/3 of all quant problems are multiple choice, like A, B, C, D, E. 1/3 are either text entry like this or select all that apply. And those little square boxes I'm drawing here, that's what you see when it's select more than one. So most are 5-question multiple choice, but there's still a sizable percentage that aren't. So you could definitely conceivably see this format. James, that would be a way of finding the median to say like, okay, I'm going to cancel one here and one here, one here and one here, one here, and one, like that to kind of do it this way to think about where our median is. Yeah. But it's not, I need to then think about like how far 110 is from the median, how far 115 is from the median, and that crossing out method doesn't account. But it's good. This is a good transition because we're going to talk about median for a minute. And then we will circle back around to mean median comparisons and distributions. Other questions about this one? Yeah. Really good thing to think of are multiple ways to solve a problem. That way you're always looking for the most efficient way to do it, and you're building flexibility. And flexibility is a key GRE skill in both quant and in verbal. Okay. So let's talk about median, because you guys are already there thinking about median. Median is the middle. If you ever get a median problem that's hard and you're stuck, just come back to this middle. If I put all of my data points in order from lowest to highest, it's going to be the one that's in the middle. Or if there's an even number of terms, I'm going to average together the two middle ones. It's like a line that cuts my data in half. And 50% of my data is on one side, 50% is on the other. What's the median of this list? Yeah. Yep, you guys got it. So I have to put them in order. Yeah, Hermione, you got it. I have to put them in order. Then I find the term that's in the middle. So if they're randomly ordered, I need to order them first. What if I took out the 11? So I had this set of terms and I said no more 11. What would the median now be? Yeah. I add, yep, you guys got it. So in this case, I have 1, 1, 3, and 4. So this is where I need to find something halfway in between 1 and 2, right? Because my median, again, is that line where I have 2 on this side, 2 on this side. So I know 2. If I had weirder numbers where I couldn't immediately see that, to find sort of the halfway point, I just do 1 plus 3 over 2 equals 2. So here's an interesting thing. Finding the average between two things is also a way of finding the halfway point. And you do sometimes see that on the GRE. Like, oh, 12 is halfway in between X and Y. It means X plus Y over 2 would equal 12. Let's do something hard. So we did something very straightforward. Now we're gonna like jump and do something tricky. It's gonna be a big gap, but we found a mean from a chart. So I thought it would be good to also think about finding a median from a graph. Here you go. All right. Give me an update. I've gotten a few answers. Other people sort of on your way there? You feeling stuck? This one is hard. The first time you see a problem like this is hard, but then the second time you see it, I think it's like, I know what to do. That's why we study. Yeah, it's tricky. So let's say I saw this and I was like, oh, okay, I have a bunch of years. So I'm just going to do that same thing where I put things in order and I start crossing off on either side. That like real classic way we all probably learned to do median, or many of us learned, at least if you went through the American educational system back in the day. Kind of crossing off. And I'd say, awesome. Must be 1991. So that's like this. But there's no answer. Then I'm kind of like, oh, yikes, there's no answer that's that low. What's wrong with what I just did? Exactly. Yep. Remember, when you're looking for median, you're not looking for the middle in terms of labeling. You're looking for the middle in terms of amount. So I'm not thinking about middle on this axis. I'm thinking about middle on the y-axis. And I'm thinking about where on this graph could I draw a line so that I'd have the same number of points above and the same number of points below. Like I could, in theory, do this problem by writing out all of these data points, like saying like, okay, that's 2.5. Okay, that's 2.6. That looks like 2.9, and write them all out and find it. But that looks like a nightmare. I'm not going to do that. That's going to take way too much time. So there has to be a faster way. How many data points are there here? How many years are we dealing with? Yeah. How do you find 19? Aside from just counting them up. What's a fast way to figure out how many years we have here? Nice. Yep. Ever want to know how many points are there in a consecutive spaced set? I just do last minus first. Yeah. Inclusive count. Yep. Nice. +1. So in this case, I have 19 points. Which of these points, like if I have the first, second, third, fourth, fifth, I'm lining them up in order, which of these points represents the median? I vote for 11th, I vote for 10th. Barath's gone way down the road. Yeah. You're good. You get it. Yeah, it's going to be the 10th point, because then I'll have 9 up here and I'll have 9 down here. So I need to find the 10th point, either by starting at the lowest term and counting up, or by starting at the highest term or counting down. So that's what I'm going to do. First, second, third, fourth. Now I have to jump over here because this is the next highest. Fifth, this is my 6th, 7th, 8th, 9th, 10th term, which is exactly as Barath predicted, our 1987 year, and our value is going to be 4.2. Yeah, Lindsay, I'm going to do it again in the opposite direction. So again, I'm imagining, and I'll re-explain it as I do. I'm imagining that I'm putting all of these points that kind of vary in value in a list from lowest to highest. So I can count it up from the bottom, but I can also say, okay, this is my biggest one. So this is going to be like 0.19. Then I look for the next biggest one. So this is going to be 0.18. Then I look for the next biggest one, 17. So I'm at 3 now. Then I go down again, 4. Now, next one would be this. Next one would be this. So I have 1, 2, 3, 4, 5, 6, 7. That looks 8, 9, and 10. So it's a way of, instead of actually having to write out all of these points and put them in the list, it's a way of figuring out how many are above and below. Yeah. Also a way of doing exactly that, saying like, okay, where can I draw a line so that there will be 9 above and 9 below? Two things that can help with this, real small things. I would literally, so you guys can't draw on the screen. The GRE is on a computer. It would be nice if you could, but alas. But you can touch the screen with your finger. That's what I would do. I would go like 1, 2, and that way I'm really keeping track of where I am. Like no one you know is in that room. No one's going to judge you for like interacting with the screen. You could also take your scratch paper, hold it up to the screen, use it like a line, move it up and down, and think again about where's that middle line. Average of highest and lowest would only work if I knew, yeah, you and I are on the same page. It's good. Only works if you know that they're evenly spaced. And these are very clearly not evenly spaced. Like there's sort of irregular intervals between them. So in this particular case, it's not going to necessarily be accurate. We're going to talk about evenly spaced sets. Any other questions about this? One quick aside, I didn't bring a problem that looked like this, but one cool thing, this works for pie charts too. Like let's say I had a pie chart and it's going to be an ugly pie chart. That's why I don't draw things on the fly. And I drew this pie chart and I said like, okay, this category, this slice represents, you know, people who scored like a 70 to 80. This is people who scored 80 to 85, 85 to 90, and 90 to 95. If I wanted to know where the median score would be, I could say like, okay, this is sort of my starting point because it's the intersection of the lowest and the highest score. And then I can just draw a line across. And so I'm like, okay, my median score is probably going to be in the 80 to 85 range. Should have drawn this out beforehand because I know my freehand Zoom drawing is not amazing. But this drawing a line, cutting it in half works for other types of charts, not just line charts. All right. Let's now talk about median versus average. Oh, yeah. Yeah, encore of the circle graph. Let's do an encore of the circle graph. Yeah, let me draw a better circle graph for you guys. Let me try and make it clearer. Yeah, so here's my circle. And I'm going to say like, okay, one category is here. No, I'm just making it worse. One category is here. One category is here. If any of you have an official guide, there's a problem like this in the official guide. I can't share official guide problems in this seminar because of copyright issues, but you can in fact find a problem like this in the official guide. So if you want a fun activity, go look for it. Let's say, okay, this is I'm going to do easier ranges. This is 0 to 2. This is 2 to 4. This is 4 to 6, 6 to 8, 8 to 10. So again, I want to cut this chart in half because that median is going to be the point where 50% of my circle graph is on one side, 50% is on the other. Because I'm saying like, okay, this sort of percentage is 2 to 4. This percentage is 4 to 6. Like my slices are different sizes. And I start at the sort of origin point. It's like, here's my high category, here's my low category. So this is like the start of the circle, and the circle increases going clockwise. Yay! Isn't that nice when that happens? You're like, I can make my life easier. And then I just draw, let's make a pink line. And then I can just draw a line across like that. And now I see, okay, cool. There's half the circle over here, half the circle over here, and my median point lands here in the 4 to 6 category. So I know my median. I don't know exactly what my median is, but I know it's going to fall in that 4 to 6 range. Anthony, it's in general thinking about y-axis with median, yes. The x-axis with average is not quite true. It'll depend like what type of graph and how things are stacked. All right. Now let's talk about average and median. Yeah, but it works for median. It's a good point for median. Okay, back to some simple calculations, but they're going to lead us to an interesting place. Here's a set of numbers. What is the median of these numbers? Yeah, 11. Nice. What's the average? Yeah, it's also going to be 11. Nice. Because, let's see, if this is my median, plus 1, plus 2, plus 2. Or sorry, plus 0, plus 1, plus 1. And then this is going to be plus 0, minus 1, minus 1. So this data is symmetrical. It's evenly spaced around that median. Here's a variation of this set of data. What's the median of this set of data? Yeah, nice. 11. And what's the average of this set of data? Hamani got 11.2. Other people agree? Someone asked a question about practice problems. What I had said, I think, was I was going to post a link to some arithmetic drills, and I did post that. I think repost that in the chat. So a little game to do some arithmetic drills. Yeah, it's a little bit higher. It's a little bit higher than the average. It's going to be 11.2. 11.3. It's a little higher. And that makes sense if we think again about the distribution. So here again, I have sort of 0. Here I have minus 1, but now here I have, with 13, I have plus 2, and I have plus 2. So 13 is contributing more to that sum. It's going to have more of an impact on the average. So the median is still going to be 11, but the sort of balancing point that all of the data points center around is going to get pulled higher. It's going to get pulled a little bit above that median because those 13s are outliers. They're my sort of skew or my tail if you took a stats class at some point. Here's a nice graphical representation of that. When my data is symmetrical, so it's balanced, evenly balanced, spaced out, sort of like, good question, BA. We can go back to that in a sec. It's sort of, I didn't actually do the full calculation with it. I just used it to deduce like how the mean and median would relate. And that's primarily how you would use that in this context on the test. If it's symmetrical, average and median are going to be the same. If it's not symmetrical, if it's skewed, the average follows the outliers. So this is true of bar graphs, but it's also going to be true of something like, say, the normal distribution curve, right? If you've seen that nice bell curve distribution, that's symmetrical. So my average and my median are the same in a normal distribution. But let's say I got a distribution that looked real funky. Looked kind of like, had this long tail, like it got stretched out on one way. My median is going to be near the peak, but then my average is going to follow, is going to move toward the tail, toward the skew. So when I'm thinking about comparing mean and median, I think about how is the data spread out? Is it spread out symmetrically? Is it spread out evenly? Or is there some kind of skew or distortion in it? And that way I can make mean median comparisons really quickly without having to do a ton of calculation. And we're going to look at 2 GRE problems where that's going to enable us to be super, super fast using this concept. You guys ready to do it? Yeah, fast ready. Yes, I think it does. I think it does help. It's kind of what I was getting at when I was sort of showing how things were spaced out around the median. We can go back to that too. We can go back to that too if we have time at the end and look at that again in light of this. Okay. So if we're thinking about comparison, an obvious type of question to look at would be quantitative comparison. I know some people are kind of starting out, you're newer to studying. What is this question asking? When I see a question like this on the GRE, what is this? What is my task? And I get some info and I get 2 quantities. Just generally with this format. Yeah, I want to know how do they compare? And what does answer choice A mean? A, yeah. A is bigger, B, and answer choice B, QB is bigger. What's answer choice C? And answer choice D. Nice. Yep, not enough info to compare, multiple possible results. There's a lot of ways to think about D. D is kind of a cool answer. So that's what we're thinking about when we answer these questions. There's 7 of them on each quant section, so they're a pretty big portion of the test. If you're just starting out, I would start with this format in quant. It's a good foundation. Okay, so when we see a QC question, we know what it's asking. It's asking to compare, but we want to think about what info do we have. So I see right away I'm comparing a median and a mean. And so what do I immediately want to think about when I'm comparing a median and a mean? What determines how? What about the data determines how mean and median relate? Yeah, I want to think about distribution. Awesome. Yep, and symmetry. So let's do that. Let's think about how our data is spread out. Which of these 3 students has the highest score? Yeah, Beth. And I know who has the lowest score? Yeah, Ari. And I know that the distance between these 2, between Ari and Beth, or sorry, not Ari, Carrie has the lowest score. Details, attention to details, key to the GRE. Yeah, I know that Carrie. And that this is 11. And then Ari's score is in the middle. Who is Ari closer to? Closer to Carrie or closer to Beth? Yeah, he's going to be closer to Carrie. Because I know that there's 6 between her. This distance here is 6. So that means this distance must be 5. All right. Which student has the median score? Which of these 3 students has the median score? Yeah, that was such an easy question. Thank you for indulging me in answering it. I appreciate it. All right. Now, is this data symmetrical? Are the mean and median going to be the same? Not symmetrical. So right away, we can get rid of C. We can also get rid of D because we know the relationship between the mean and the median is fixed. It's not going to change. The data's already been distributed. So now, worst case scenario, we have a 50-50 chance of getting this right. Is the mean going to be above RE score or below? Where is the data stretched? Where is there an outlier here? Yeah, nice, Semi. Nice, Mikhail, Nana, Rath. Yeah, the mean is going to be a little bit above RE score because Beth is my outlier, right? I have a bigger spread toward Beth than I do toward Carrie. So what's my answer? Yeah, my answer is going to be A. Nice. There are other ways to do this problem. You can do this problem with algebra. You can do this problem by picking values for the scores and calculating it this way. But I really like this distribution. Anytime I see average, median, mean being compared, I like this distribution method because to me, it's super fast. Like just think about evenly distributed. Nope. Okay. Where's the tail? Where's the skew? And then got my answer. The tail that tells the tale. One of my students gave that to me. They're from their college stats professor. Lindsay, yeah, we don't know what the actual value of the median, never dumb question. We don't know what the actual value of the median is. Like Carrie could have scored a 0, Ari could have scored a 5, and Beth could have scored an 11. Or Carrie could have scored like a 20 and a 25 and a 26. So I can't actually calculate a precise value for either the average or the median without having the data. But I don't need to. Yeah, I'm glad you like it. I don't need to calculate that because all I have to do is compare. So with QC, we're always thinking compare, and we don't necessarily have to have precise numbers to get to an answer. It's one of the big things you want to remind yourself of constantly when you start working with these, like compare, don't calculate. We're going to do one more. We don't know the median. Yeah, we don't know what the median is, but we know that it's going to be lower than the mean. Yeah, what should stand out is that Beth, so Ari is our median, and Beth is further from the median. The distance between Beth and the median is further than the distance between Carrie and the median. So that's our outlier. Like if we went back for a moment to the previous slide, it's like this is, this is Carrie, this is Ari, this is Beth. Beth's that outlier score that's further away from that middle point. Yeah, Lindsay, that's a good way to put it. Yep. Does that help, Brittany, Casey? We have about a minute left. So what I would love you to do in our remaining, further imagine that like the further flung thing is like pulling the average toward it. It's like stretching the average up toward it. If you like, I like everyone chat in one thing you learned today that you're gonna take out and use in your studies. Let's make a list before you all disappear out into the night. Always a good thing to do at the end of a study session. Summarize what you've learned. Yeah, stats from graphs. Find averages from charts. Mean without calculator. Thinking about sort of spread. Yeah, cut graphs in half or median. Nice. Mean versus median is about distribution. Yep. Median equals middle value, not middle label. Awesome. Use tables. Yeah, tables, ratios, stats, odds and evens. Tables come up again and again. Super useful tools. Yes. And pay attention to details. Yep. And I'm going to leave you guys with this. What is the question asking? What info do I have? You now know how to start every quant problem you're going to encounter with these two questions. Thank you all for coming tonight. Happy studying. Best of luck. We do these free prep hours a couple times a month. I'm doing another one in December. My colleague Kaylee does some. So come back if you're still studying. And otherwise, have a great night and good luck.